All right, let's talk about something that's practically guaranteed to pop up in your coding interviews and exams. It's the foundation for so much of what we do in programming. Today, we're going to master arrays.
So picture this, you're sitting in that technical interview, the pressure's on, and they slide that first problem over to you. What do you think is at the heart of that crucial first question?
Yep, you guessed it. 9 times out of 10, it's going to be an array. Arrays are just these fundamental building blocks. So our goal today is simple. We're going to walk through the most common array problems, from the easy ones to the real brain teasers, so you can walk into any test or interview feeling totally prepared.
Okay, before we start solving anything, let's get a quick refresher. Let's make sure we're all on the same page about what an array actually is.
The easiest way to think about an array is like a row of mailboxes, all right next to each other in your computer's memory. Each mailbox has a number on it, that's its index, and remember, they always start from 0. And inside each box, you can hold one piece of information. It's this simple, ordered structure that makes them so incredibly useful.
All right, foundation is set. Time for a little warm-up. These are the absolute basics, the moves you need to have down cold before we get to the fun stuff.
These are your 4 essential drills. First, traversing. That just means visiting each mailbox one by one and printing out what's inside. Then, calculating the sum. Well, you're just adding up the numbers in each box as you go. And finding the largest or smallest element, you just keep a running track of the biggest or smallest number you've seen so far. Simple, right? But seriously, mastering these is the key to everything else.
Okay, warm-up's done. Now we're moving beyond just reading the data to actually changing it. This is where the real puzzles begin, where you have to start manipulating the structure of the array itself.
So here's our first puzzle. You've got this array on the screen. How do you flip it so it reads 8, 2, 4, 1, 5? Go ahead, take a second and think about how you do it.
You know, the most straightforward way is to just create a brand new empty array. Then you just walk through the original one backwards, starting from the last element, and you pop each item into your new array one by one. It's clean, it's direct, and it gets the job done perfectly.
Now this is something interviewers love to do. They'll ask questions that sound really similar, but require totally different logic. So for example, finding duplicates means you're looking for repeated numbers inside just one array. But finding an intersection, that's about comparing 2 different arrays to find what they have in common. See the difference? It's a subtle but crucial distinction.
We've covered the basics. We've done the manipulations. Now it's time for the final challenge, the boss level. This is where we move past simple loops and start thinking with more elegant, efficient algorithms. This is what interviewers are really looking for.
Ah, a true classic. This is called the two-sum problem. You get an array of numbers and a target value. Your job is to figure out if any 2 numbers in that array add up to that target. In this case, our target is 9. Can you spot the pair?
So the first thing that probably pops into your head is what we call the brute force method. You just check every single possible combination, right? You try 2 plus 11, then 2 plus 7, then 2 plus 15, and you keep going. And yeah, it works. It'll get you the answer eventually. But for a really huge array, it would be painfully slow. There's got to be a smarter way.
And here it is. This is the aha moment. Instead of checking every pair, we're going to flip the question on its head. For every number we look at, let's call it x, we calculate what we need to reach our target. We'll call that its complement. Then we just ask a simple question. As I've been walking through this array, have I already seen the complement number?
Let's walk through it with our example. Our target is 9. We start at the first number, 2. The complement we need is 7, right? 9 minus 2? Have we seen a 7 yet? Nope. Okay, so we'll just remember that we've seen a 2 and move on. Next up is 11. Its complement is -2. Haven't seen that, so we remember we saw 11. Finally, we get to 7. What's its complement? 9 minus 7 is 2. And we ask the question, hey, have I seen a 2 before? And yes, we have. Boom, we found our pair, 2 and 7. See how much faster that is?
And that right there is the leap. It's the jump from just writing code to thinking with algorithms. So let's quickly recap what we've covered.
We started with the absolute fundamentals, just getting comfortable with arrays. Then we leveled up to manipulation puzzles like reversing and spotting those tricky logical differences. And finally, we hit the boss level with two-sum, where we saw how a smarter approach can totally crush a brute force one. Mastering these patterns is what really separates the good programmers from the great ones.
We've seen just how powerful arrays are, but their biggest strength, that neat, fixed-size row of mailboxes, is also their biggest weakness. What happens when you run out of boxes and need to add more? Or what if you need to pull a box out from the middle of the row without leaving a huge mess? Well, that opens up a whole new world of challenges. And maybe, just maybe, the topic for our next explainer.